This is about functions. Going to talk about some basics about what makes a function. First off, there's a concept of input and output. That's dealt with generally in society, but in math we'll use some more specific terms. We will call input the domain, and we'll call output the range. In science class, you'll often talk about this, and we will here as well, the domain as being the independent variable, the range as being the dependent variable. The domain will almost always be referred to as the x and the range as y. Sometimes the y will also be called f of x, or the value of the function at x. The x value, of course, on a graph is represented on the horizontal axis, this way, and the y on the vertical axis, up and down. Now, something about the function that's really important. Here's a concept that we talk about, and it says for every member of the domain, there is uniquely one member of the range. So, uniquely one. That's a concept that we talk about in math language. It means that there is one and that there is only one. So for this circumstance, if there were more than one output for every input, then it would not be a function. If there were more than one member of the range for a particular member of the domain, that would mean that it is not a function. So we've got a little example here to help us with that. Froggy and Doggy are going to help us illustrate this. Okay, so Froggy and Doggy like to talk to each other. So Frog will say a number, and then Dog will give a response. And we can illustrate what a function is with that. Okay, Frog comes up and whispers into Dog's ear and says 2. Dog thinks about it and says 3. Frog comes and walks up and says 7. Dog thinks about it and says 8. Frog says 2. Dog says 3. 5, 6. 2, 3. Okay, so now the question is, can we rely on Dog to give the same answer every time Frog says the same thing? Well, yeah. Frog said 2 more than one time, and every time Frog said 2, Dog said 3. So yes, this is a function because it's reliable. The member of the output corresponds to the input. There's only one output that's the same every time when the same input is given. Okay, well, how about this? 7, 5, Doggy says. Froggy says 8. Dog says 5. 9, 5. -3, 5. 1.72, 5. It turns out that the only thing that Dog knows is the number 5. So whenever Frog says something, Dog says 5. Is this a function? Okay, well, let's see. Every time Frog said a particular number, he got the same response. So we can rely on Dog to reliably give the same answer to the same input. So is it true that there's uniquely one member of the range for every member of the domain? Yes, it is true. Notice that only goes from Frog to Dog, from domain to range. We don't go backwards. It's okay that every answer that dog gave was 5. We don't care. But what's important is that when a particular question or input was asked by Frog, the domain, that he always got the same answer in the range. Okay, so now I'm learning how to do this, sorry. Okay, let's look at what some of these look like. Okay, here we have, I want to know if this is a function. Every time the input is 0, is the output 5? Yeah, it's only there once. 1 is there, every time there's a particular input, we get the same output. There's only one time, so it's not really that big of a deal. Okay, let's look at this one. When input was 7, output was 13, but look here. When it's 21, we get 13. Is that okay? Oh yeah, that's just like the froggy who only knows the number 5. That's okay. Every time we said 7, we got 13. We only said it once, and that's okay. So let's look at another way to show these. Right here. Okay, this is a mapping function, a mapping illustration. Notice that here, input is 1/2, we get 0. 2/3, we get 1. But look here, 3/4, we could have 2 answers. So when the input is 3/4, the output could be either 3 or 4. That's not unique. There is one answer. In fact, there's 2 answers. There's not only one. So this is not a function. Okay, so now we're asked to make a table of this function and to identify the range. So we're going to make the table only for the domain as it's given here. So let's make a table. Make a little T-chart. It can either be vertical or horizontal. It doesn't matter. I'll make this one vertical. Our 2 variables are x and y. The domain that we want is 0, 5, 7, and 10. Those are the only ones we want. We don't want others, although there might possibly be some. So let's look at it. We'll say 0 in for x. 0 times 3 is 0, plus 4 is 4. We'll put 5 in for x. That'll be 19. Put 7 in for x, that'll be 25. Put 10 in for x, that'll be 34. So we've made the table, and now we need to identify the range. Well, there it is. It's right there. That is the range, but we need to write it out so folks know we know it. So we'll write out that the range is 0, 19, 25, and 34. That's one way to write it, and that's a good way. Another way is in the set terminology. This is called a brace, and we'll just put them all in as a set like this. Okay, both of these ways to write it are just fine. You can choose whichever way that you would like. Okay, so what did we do? We took a function, y equals 3x plus 4. We wanted a specific domain. We made a T-chart so that we could have that to organize our thoughts. After we completed the T-chart, we saw that the range or the y values, and we listed them, either just in a list identified as range or also in a set terminology in braces.